Chapter 4, Properties of Parallelograms. We did the pre-Chapter 4 practice and review. So our focus here is parallelograms, and we'll also talk about trapezoids, which are not parallelograms, as we'll discuss later. Definition of a parallelogram. The symbol, I call it a whumpy-jawed rectangle. Kind of like you had a rectangle and you went whack, and it just kind of knocked it all crooked. Anyway, that's kind of how I think of it, whomper-jawed rectangle. Anyway, some of my country talk, I reckon. But a parallelogram is a quadrilateral. That means it's a four-sided figure. A quadrilateral with both pairs of opposite sides parallel. A parallelogram is a quadrilateral, that's a four-sided figure, with both pairs of opposite sides parallel. The way we show the parallel, excuse me, accidentally drugged the bottom. The way we show that the sides are parallel, remember, are the arrows in the middle of the line, so the little arrows in there show that both pairs of opposite sides are parallel. There's three special types of parallelograms: a rectangle, which by definition is a quadrilateral with four right angles; a rhombus, which by definition is a quadrilateral with four equal sides; and a square, which by definition is a quadrilateral with four equal sides and four right angles. It would be a regular, if you recall that term, both equilateral and equiangular, a regular quadrilateral. So a rectangle is an equiangular quadrilateral. A rhombus is an equilateral quadrilateral. A square is both equilateral and equiangular, which we call a regular polygon or a regular quadrilateral. Properties of all parallelograms, be they whomper-jawed rectangles or rectangles, rhombuses, or squares. The properties of all parallelograms are both pairs of opposite sides are equal. Both pairs of opposite sides are parallel. I did that in a different order. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary, which means that the sum of their measures is 180 degrees. And the diagonals bisect each other. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. Congruent means same size and same shape, which we will talk about in chapter 6. Okay. So in parallelograms, both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. And here you can kind of see that in your student edition. This is all filled out as it refers to the picture. And so we'll go down to the picture and kind of look at that. So in the picture, we can see that both pairs of opposite sides are parallel. So we could say that AD is parallel to BC and AB is parallel to DC. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal, so we could say that AB is equal to DC and AD is equal to BC. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal, so this angle here is the same measure as that angle there. So angle ADC is equal to angle ABC. And then the angle over here is the same measure as this angle over here. Angle DAB is equal to angle DCB. The diagonals bisect each other. That means they cut each other in half. That means that the segment from here to here, AE, is equal to the segment from here to here, EC. That was an E in the middle. Let me clean that up a little bit so we can see. If the diagonals bisect each other, then this segment AE is equal to this segment EC. And this segment DE is equal to this segment EB or BE. The diagonals bisect each other. Consecutive angles are supplementary. You can see why they make a C. Same sides make a C, and they're supplementary. But consecutive angles are one right after the other. So we can say that angle BAD plus angle ADC is equal to 180 degrees. Same sides make a C and they're supplementary. Same side interior angles are supplementary, which proves that consecutive angles are supplementary. And we could do this pair. We could say that pair is supplementary. Or we could say that this pair is supplementary. Or we could say that this pair is supplementary. Consecutive angles are supplementary. There would be 4 pairs of consecutive angles. And then we can say that each diagonal forms a paracongruent triangle. So if we drew a diagonal, that's a segment joining 2 non-consecutive vertices of a polygon, then the 2 triangles formed are congruent to one another. We will want to name those congruent parts in order. So if we name the black one DAB, we need to name the red one in the correct order. Angle D is actually the same measure as the B over here, so the B would have to go first. And A is the same as C over here, so the C would have to go in the middle since it corresponds to that A. And then the B of this triangle corresponds to the D of that triangle. And so there's the pair of congruent triangles. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. There's 6 properties of all parallelograms. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. There are 3 special types of parallelograms, which we will study later. The rectangle, which is an equiangular parallelogram or an equiangular quadrilateral. All the angles are 90 degrees. A rhombus, which is an equilateral quadrilateral. All of the sides are equal. And a square, which is both equilateral and equiangular. So we would say that it was a regular quadrilateral. Those are 3 special types of parallelograms, each having their own special properties beginning with their definition. Okay? And so that brings us to the daily work, and so we'll stop the recording and record the daily work.